Now we move on to Module 13, where we're going to be looking at graphing and specifically graphing equations of lines. And so our first unit is introducing equations in two variables. So here's an example of an equation in two variables. A plus B equals 12. Okay, so as you know, variables mean those values can vary. They're kind of like our mystery numbers. And you might imagine how those could take on several different values and still have the equation be true. So for example, maybe this equation, maybe A is the amount of money Annette has and B is the amount of money Bill has, and together we know they have $12. Well, there are several possible answers to how much each Annette and Bill have. Maybe Annette has $4 and Bill has 8. Maybe they each have $6. Maybe Annette has $0 and Bill has 12. So there's many possible solutions to this equation. And so equations in two variables can have many or even infinite solutions. And we write those solutions as ordered pairs. So for example, 5 comma 7, where the first value is the x variable or the first variable, and the second value is the second variable, which is typically the y value. So for example, and we've done some of these in the past, but just as a bit of a review, we're asked to find the missing number in this ordered pair, -3 comma blank. So we have our x value here of -3. We want to figure out our y value that would make this an xy pair that makes this the equation true. And we want it to be a solution to this linear equation here. So in other words, what does y have to equal if x equals -3? So what you want to do is replace the x with a -3. And so be careful with your negative signs here. We had negative x, so that's going to become negative -3. And then we have +4. That gives us +3 plus 4, or 7. So therefore, we end up with the ordered pair, -3 and 7, which is a solution for the equation. It's not our only solution. There are many, there's actually infinite solutions to this equation, but it is one xy pair that makes this equation true. The other thing we could be asked to do is to check if an ordered pair is a solution to an equation. So if you're given a full ordered pair, like an x and a y value, you can put those variables or put those numbers in for the variables in the equation, simplify both sides, and see if you end up with a true statement. If you do, the ordered pair is a solution. If you don't, it is not. So here's an example. We want to know if the ordered pair 5 and 9 is a solution to this linear equation here. So remember, ordered pairs are always x value first, then y value second. And so we're going to replace our x in our equation with a 5 and the y in our equation with a 9, which is what has happened here. So this is this same equation. We just now are putting a 9 in for y and a 5 in for x. And then we end up with 9 equals 2 times 5 minus 1, which simplifies to 9 equals 9. That's a true statement. So yes, 5 and 9, that ordered pair, is a solution to this equation.